The goals for this online video are to show you how to write an explicit formula for a sequence and how to write a recursive formula for a sequence. So let's look at this first sequence here. It's infinite, it goes on forever, and it starts at 3, and then each time it's going up by 4. So this one would be 3 plus 4, which would give you 7. The next one is going to be 3 plus 4 plus 4, so there's 2 4s, so just 3 plus 4 times 2. The next one is 3 plus 4 plus 4 again, so it's 3 plus 4 times 3. And as you can see, each time we're going down by 1, what we're multiplying it by here. So this would be 3 plus 4 times, if it's at 10, this would be 9. So the formula for this one would be 3 plus 4 times n minus 1. It's always 1 less than the term, what we're multiplying it by. So I'm going to distribute the 4 and I get 3 plus 4n minus 4, which would equal negative 1 plus 4n. So this is an explicit rule for this series. So what an explicit rule means is that I can plug in any term and get the value. So if I wanted to plug in a 100, that means I could simply plug in negative 1 plus 4 times 100. So that would equal negative 1 plus 400, which would equal 399. So what's really nice about an explicit rule is you can simply plug in any term and find that value. Another formula is called the recursive formula. With the recursive formula, you go up, you look at the terms a little bit differently. This one's just really simple idea. It just has weird notation. So if you look at the first one, A1 is 3, and then we would describe A2 as simply being the previous one plus 4, because each time we're adding 4. So the previous one, with the recursive formula, we describe as being A n minus 1. So when you have A with the subnotation n minus 1, it's just talking about the previous one before it. So A2, the previous one would be just 3 plus 4, and that would give you 7. So that would just be the previous one to A2 would be A1, so that would be 3 plus 4, which equals 7. So that checks out. Then A3, we would describe it also as the previous one plus 4. And that works because the previous one is 7 plus 4, which gives you 11. So the rule is set up for us automatically here. It's the previous one plus 4. And the recursive is really easy to write, but it's not as useful as the explicit formula, because the explicit formula, I can just plug in a term to find its value. And with the recursive formula, I can't. So we've written out the different terms of the sequence, but let's talk about how we would formally write out a recursive formula. Would just be this. The recursive formula for this rule is when A1 is 3 and AN is the previous one plus 4. That is a recursive formula. A recursive formula is really easy to write. It's got weird notation. We'll go over this more in class, but it's not as useful as the explicit formula because I can't simply just plug in a value. I can't say, oh, what is a 100 with this formula? I would have to go through every single one of these. I would have to know what A99 was, what A70 is, everything from A1 through A99 in order to get to A100. I couldn't write this in unless I had a lot of time, which we don't want to spend. I would need to literally write out the pattern in order to do this. So a recursive formula is just a way that you can write these out more verbally. So this is just the notation for the previous one. So n minus 1 says the previous one plus 4 when we're starting at 3. So why do we even use a recursive formula if it's not as useful? Is because some patterns that we have cannot be written with an explicit formula. And we'll investigate more of those in class.